So for the kind introduction, I'm very happy to be part of this program, very interesting and a very useful program that IIST has put together for the benefit of, I think, specifically the teaching community. So yeah, I would like to share some of my own thoughts on the topic given to me. Let me share my screen. Okay. Okay, I hope everyone is able to see my screen.
Yes, sir.
Yes, sir. Very able.
Okay, good. Yeah, so a disclaimer straight away that these are my thoughts. So other experts may have somewhat different views on this. So don't take that this is the absolute truth. First, I'll share some thoughts, about, in a generic sense, what is the approach to research, and I'll follow it up with some issues I feel in the MTech program, ME-MTech program, the way it is structured in India and why it's not producing, research output that is really expected or desirable. Okay, so these are not for, fellow professors from IITs, IIST or IISC, etc. These are generally for faculty members who spend more time teaching and who are now interested in research. So, in my view, very difficult to provide a sure shot formula for producing research work. So what is essential is that there has to be some original thinking. If you have a research area, if you have a field or an area and you want to pursue research in that, you should have some creative thinking of your own. Okay, otherwise you can keep reading papers published in conferences and journals and you'll be doing it forever. Okay, at the same time, the researcher should also be aware of what's happening. So it's not to say that don't read or don't follow others' work. That is also equally important. Some years ago, I came upon this particular talk by Professor Richard Hamming, R.W. Hamming. So electrical engineers know what is Hamming code, etc. So his talk is, it's highly motivating, and what he says is essentially you should aim for great great research. You should not set your bar low. You should set your bar high and pursue it with all your energy and focus. And in my view, a researcher should be able to critically read others' work. One should not be impressed, or one should not be just an admirer of others' work. One should be able to critically read it, identify the gaps, limitations, and only then one can come up with ideas as to how he or she can contribute. So critical analysis of others' work or the state of the art is very, very important. So a researcher should identify the area of his or her interest. It can be anything, okay? And now you have to gather relevant info data about that area, from historical developments till state of the art. It does. I don't mean that each and every one of tens of thousands of papers should be read by you. Some of the important ones. So, how did this field come about? And what is the latest in that field? So, if you are interested in conducting research in a particular area, you should know what's happening recently and how did that area start. What did it develop? What did it start with? For example, if we are talking of artificial neural networks, so you have to know what is a perceptron, uh, maybe uh, how the ideas came about, where it stopped, how it again picked up. So these initial thoughts will tell you that the success of a neural network depends on how good your training algorithm is. So one can't directly go to developing a new training algorithm. So if you are working with neural networks, start with, first some idea. If you are entirely new to it, first you should have some ideas as to what is that field about, what are neural networks, or why are they important. Some history also is equally useful. Okay, so then you have to identify uh, an opening for your own contribution. So if you are able to do that, then you have to now come up with a precise research problem. First is, okay, I want to work in neural networks. I want to work in, say, support vector machines. I want to work on something else, whatever is that. Okay. So I start getting an idea about what is its status, why is it important, is it still active. So once I know that, then I now say, okay, looks like this bit is not as much explored as something else. So let me see if I can contribute here. So once you get that idea, now you form a precise research problem. Okay. So once that is done, then we should have a methodology to solve the problem. How do you solve it? How do you come up with a new training algorithm for a neural network? Or how do you remove the distortions in an image? So, or how do you classify a particular data set? How do you estimate the parameters of a distribution? So it can be anything. Okay. So once you have the problem, you try to develop a methodology. Now you develop a solution, but at the same time, you should also be careful that you are able to justify that whatever approach you have taken is the right one. Okay. It's not just that, okay, MATLAB supports a particular set of functions, so whatever is possible, let me use it. Not that way. There has to be a good justification for it. And then you should do proper testing and validation of the methodology. Okay. So this is how typically research progresses, and when you read papers, these are the kind of things that you will generally find. I have a request to the audience. Please mute yourselves. I'm getting some disturbance here. Audience may please mute themselves. So now comes the important point. In order that you develop an idea of what is happening in the field, you should be able to read published work. So how do you read published work? Because it's not reading some English text. When you are reading research papers, so there has to be a proper structured way of reading such papers, reading such research work. What is the subject area? Let us say, what is the subject area? If it is geoinformatics, maybe it is, say, some spatial analysis problem.
Hello, Lakshmi Prasanna Rani Garga. Kindly mute your phone or unmute YouTube.
Yeah, M. Lakshmi Prasanna Rani, can you please mute yourself? You can also, stop your video. Are you able to hear me? Okay. So what is the methodology that is adopted? What is the subject area? And what are the aims and objectives of the paper that you are reading? And what is the idea of the authors of that paper, according to which, what are the limitations they have identified in the state of the art, okay, based on which they they did their work and published it. And what is the exact problem they solved? So you have to, follow actually the paper so that as you read it, you should get this idea. Okay, according to the authors, what are the limitations in the state of the art, okay, as on the day the paper was written, and what is the exact problem they solved? What is the methodology adopted by the authors? What assumptions they made? What data sets they used? What conclusions they drew from their work? So you are with the authors in reading and understanding the work as reported by them. Okay. Now you have to, critically look at it. So reviewing others' work is not the same as reporting others' work, right? So how do you view a paper published by somebody else? So you have to think for a moment. You are going to judge whether the paper is, say, publication worthy, or whether the paper is good. So understand what is presented in the paper, and now you have to provide your own value addition. Is the problem novel enough? Okay. Or is it some minor cosmetic improvement to an existing problem for which there are solutions already available? Validity of the assumptions made by the authors. Okay. So there are some assumptions that people make. For example, in classification, we assume that the class conditional probability density functions are all Gaussian for supervised classification. So are such assumptions valid in the present context? Have they just assumed it for simplicity's sake? Or is there some justification for making such assumptions? And what data sets are used by the authors? So if somebody used a small toy-sized data sets and on that basis they made big claims, then you should be careful in believing it. You should also look at the correctness of the methodology, scalability. So the authors proved their approach with small data sets, but will it work if the data size is, say, 100 times bigger or 1,000 times bigger? How are the results validated? Are the inferences accurate, realistic, or are they exaggerated? So these are the kind of things that you have to, consider when you are reviewing a paper, when you are reading others' work. So you can, for example, see, are the assumptions made by the authors too restrictive? Can you relax the assumptions and make a generalized version of that approach? Is there a way you can make the algorithm scalable to large data sets? So you have to ask questions. Suppose a method is applicable for, say, optical or standard color imagery. So can you make it work with laser or radar images? What difference or what additional work you have to do so that the approach of the authors can be extended? So if you have to also make some contribution, you have to ask questions. Okay. It's always good when you are about to start research, you have to assess your own strengths and weaknesses. So this assessment will not stop you from doing research, but it should help you to build up the required fundamental knowledge on the basis of which you can build your research. Okay. So when I think about it, I look at it this way. Try to ask questions starting with, say, what. So they let you test your own knowledge. So what is, for example, wavelet transform, or what is data compression? What is supervised classification? What is high-risk corner detector, support vector machine, RBF network, etc., etc.? What is the cocktail party problem? You should know that cocktail party problem is not about having cocktails in a party, but it is about independent component analysis. So if you keep asking questions starting with what, you will know how good your preparation is to take up research in a particular area. Okay. So you should have the essential theoretical knowledge, okay, before you undertake research. For example, if I want to do something in, say, very advanced machine learning, but if I have no idea about optimization techniques, then I'll struggle. Or if I don't have good idea of linear algebra, random variables, I'll struggle, right? So you have to keep asking questions, or you have to assess your own strength of fundamentals. In my opinion, this will be helpful. Just ask questions starting with what. So if you are For example, you're trying to develop a new method involving, say, differential equations. So how do you solve system of partial differential equations? How do you solve a nonlinear, constrained optimization problem? Or say, what is the solution to a constrained nonlinear optimization problem? So this will help you in assessing this is a starting point really. So what do you know, so that what more you should know, you will assess to take up research in a particular area. Now, you should also be familiar with the required tools and techniques, okay, so that when you have some ideas, you should be able to implement them. Say, how is the wavelet transform efficiently coded? How is a very large data set handled? How is the solution to a quadratic optimization problem implemented? How is the data set nonlinearly transformed? How do you compute mutual information between variables? So these are some examples. Or how do you say, if something is not readily available, how do you develop a solution to it? So these days you have a lot of libraries for or toolboxes for MATLAB or for Python, etc. So you should be able to identify the right set of tools and you should correctly use them. Okay. And then comes your ability to convince others that what you did is the right thing and what you got is a good result. So why is this problem relevant? Why do you want to work in this area? So whenever students are beginning research and when they say they want to work in a particular area, these are the questions students answer. Why is this problem relevant? Okay, or when they come up with some solutions, why is this an optimal solution? Why is this methodology the best choice? Okay, why is this assumption made while developing the solution? Why are these results good in your opinion? So you have to justify. Then only you will be able to, convince others, convince referees of journals, editors, so that your work can be published, your thesis can be accepted. So some useful general skills, mathematics. So the more mathematics you know, the better you are at research. So linear algebra, probability, optimization, data structures, algorithms. So you can have a list that is 10 times longer than this. I just put down a few. And what should be your attitude during research? Be your own harshest critic. Before somebody points out a mistake, you should be critically evaluating your own work. Okay, if you are really satisfied, then only you will be able to satisfy somebody else. If you know you didn't get a good output, but still you are presenting it to others, then you will not be able to satisfy the other person. And there should be no black boxes. Suppose you got some output and say you cannot blame it on some programming library or some toolbox. You have to explain what you did, with what ideas you used a particular library, particular function, etc., etc. Okay, so I am with experience. I'm saying this during vivas and interviews. I get to hear from students, how did you do this, or why did you do this? There is a function in MATLAB. What does it do? The student will just give me the function call. So this kind of black box approach to, using the tools is going to be a serious problem. Okay. So this is particularly something that you should impress upon your students, that they should understand the effect of each and every parameter used in the programs. And the results they should be able to explain. Okay. How they got good results or why they didn't get very good results. So more than the actual results, ability to explain that the results are good or not good, where things had gone wrong, that understanding is a lot more useful and critical. Okay, so any methodology, any technique developed should be evaluated with several data sets, more the better. And making big claims with very limited data set can be risky. Then comes research presentation. So very often I see students not taking enough care about research presentation. So the formulation of the problem should be clearly explained based on the inferences drawn from literature review as basis. Okay, and what is the model developed, linear model, nonlinear model, etc. And all the good points of the work, defend your results, highlight the novelty and innovativeness. And here comes this important point of good communication and presentation skills. Very often the students don't think that whatever whether they are writing a report or whether they are presenting something is for others. They think it is for them to get the grade, to get the marks. But actually this is for others. There are others who listen and who watch your presentation should understand it clearly. And when they read the report, whether it's a technical report or a paper, whatever is done by the student should be well understood. So this particular thing is the least emphasized as far as I can think of in particularly at thesis level. Very often students don't put enough effort in making clear presentations or in writing good reports. So this is important, that the student should realize it is for the benefit of others who are evaluating their students' work. Okay, so whoever is evaluating should clearly understand the work from the report submitted and from the presentation made. Otherwise, the effort put in by the student will not be appreciated. Okay, so these are some of my own thoughts on research. So at master's level, it will be a limited period research for just 1 year, and if it is doctoral, it will be 4 to 5 years. Professor Ramarao, can I continue or should I pause for any questions?
Your choice, sir. If you would like to have questions asked, that's all fine. If we have time.
Yeah. Audience, if you have any questions, you can ask now, then I'll proceed.
Audience, please mute, unmute yourself and you can have question.
So whatever I was
Sir?
saying, yeah, please.
Good afternoon, sir.
Good afternoon.
Sir, these days, as research is progressing very much, so a general trend is seen. Suppose there is a topic, then for a few years it is into great hype, and
Yeah.
most of the works are on that. And so, if you are working on any such thing, then how you should you try to find the research gap or get an innovative idea, not the research gap, but to get an innovative idea from that field. Suppose if today I talk about computer vision, there's been so many work going on. So is it like discussion should be there, or what strategy should we do so that
See,
we can find some
computer
innovative thing in it?
yeah. So if you say computer vision, it's like computer science today, very, very vast. So in computer vision, what are you interested in? For example, are you interested in, for example, say a video
Say LiDAR
compression,
with computer vision,
LiDAR with computer
visualization.
visualization. So if you home in on that, then is it a current problem? So start with 2020, look back 2020, 19, 18. Is there any work in the last 3 years in the area in which you are interested in? If there are still papers coming, probably it is, an area worth pursuing further. But in the last 3 years or 4 years, if nobody has published anything on this, it means that the field might have been saturated, and maybe people are no longer interested in that. That is like, one thumb rule like thing you can say. Of course, you can always take up a problem that people stopped working on, say, several years ago, and come up with an entirely new approach to it. And then, it can trigger a very new, line of thinking. A best example is, say, I think independent component analysis, probably, or support vector machines. So, a lot of work was done after early work on that, many years ago, and did not go very far, either due to computational complexities, or maybe people were not interested in that, or the funding agencies were not very convinced, whatever. So there will be a pause, and then later on it will pick up again. I mean, one more example you can think of is the multi-layer perceptron neural
Perceptron,
network.
MLP.
Yeah. So the fact that at least one hidden layer will solve the problem that simple perceptrons, whatever they failed in, at least with one hidden layer, that problem would be solved. That was known in the early 70s itself. But people did not know how to, train such networks, and only in the 80s, these MIT guys, Rumelhart and Hinton, though they came up with an algorithm, and that triggered a lot of work. And then, Thomas Cover's theorem in 70s, I don't know, 60s or 70s. Cover's theorem was just a theorem. He was a professor of statistics. And then suddenly it was used in radial basis function neural networks and kernel based computing. Then it found its way into support vector machines, and it completely changed the way things work. Today we use it very, very routinely, but it all was hiding in a statistics professor's theorem. So you have to, if you are familiar with the core subjects, they will trigger new ideas for you.
Okay,
Otherwise, yeah. So that's why the more maths you know, that will help you to critically look at what is published, what is whatever work others are reporting, and then you will be able to critically look at it, take it apart, and reframe it in your own way to do some original work.
Thank you, sir.
Yeah. Anybody else? Okay, this issue of lack of strong research contribution from master's program.
Sir,
yeah.
One question is from Nisha Elsa Varghese.
Okay.
Sir, can you suggest your opinion on whether deep learning or basic machine learning techniques are appropriate for doing research on remote sensing image mining?
The answer is yes, because if you see the IEEE transactions, geoscience remote sensing, or the JSTARS remote sensing letters, or geoscience remote sensing letters, or IGAR's conference proceedings, Whispers conference proceedings, we will see whole remote sensing field full of applications based on deep learning, deep machine learning and deep learning. So obviously remote sensing can exploit the developments coming from machine learning. There is no second thoughts about it. The only issue here is this: is the problem that you have in mind really in need of deep learning or simple shallow learning? So whether a simple neural network or a support vector machine adequate for your problem, or is the relation between your input data and the inferences you are trying to make, the interrelationship is so complex that you have to go into deep learning. Say, well, convolutional neural networks, let me be more precise rather than saying deep learning. Let's say, for example, do you require convolutional neural nets for your particular problem, or simple one layer, two hidden layer neural network or an SVM, will that do for you? So that assessment is important. My students have published papers, using both simple machine learning algorithms or using convolutional neural nets and LSTMs, etc., etc. So you need to have a proper, strong justification for using a particular technique, okay, to solve a particular problem. Because one of the things that anybody will ask you is, does your problem require deep learning? So you have to justify it. Some problems, yes, you require deep learning. Some problems you don't require deep learning. Okay. Here, when you come to the master's program in India, the IITs and deemed to be universities have some flexibility. They are in control, whereas some of the engineering colleges that are affiliated to universities are bound by what the university has framed, whether it is a syllabus, whether it is the relative weight for the semester end exams and in-semester evaluation, etc. So we at IITs, we have much more control on how to conduct this. Maybe universities have a lot of restrictions. We can adopt textbooks, suppose a very good new textbook is published last month, I can immediately adopt it. Whereas universities have a whole long process for it. So, whatever I'm going to present is more from a general university point of view rather than the IITs and IISCs, etc. So in India, when you want to know why the research is not strongly blended with the master's program, first you have to understand the program. Typically 2 years, 50% of the time for coursework, 50% for the thesis. Okay, and the courses that a student attends are generally follow-ups on the bachelor level courses. Okay, and the dissertation topics, instructors suggest some topics and students choose from them. So courses, classroom-based courses, well, lectures based on 1 or 2 textbooks. So you cover chapter 1, 2, 4, 6, 7, 9, semester is over. Now, if you are talking of masters and blending research, is a student asked to refer to any journal papers for any of the content covered in the course? Okay, so I for one know this happens in IITs definitely. I don't know whether it happens everywhere else. So does the student refer to any journal papers during the courses? Does the student get to review a paper as part of a homework assignment? Does the student implement an algorithm in an innovative way to get a good, deep understanding of how the algorithm works? Okay, with all the user controllable parameters. So small things can, make a big difference to the way the courses are taught in classrooms. Lab courses, well, I know in some of the lab courses, in some places, they are all software package oriented. So a student may understand how ArcGIS or NV or AutoCAD or such software works, but the underlying GIS or image processing or design knowledge may not be strengthened enough. The student may only be able to operate the software. I'm not saying operating the very complex software is any less important. It is equally important, but along with it, one should know when to use a particular feature of the software. That is where the students' core understanding of the subject area comes in. Are the algorithms underlying the tools in the commercial software understood? So if the student not only operates the package, but also reads the technical manuals and looks at the references associated with each of the functions, then the student will know what is the underlying principle. Okay, for example, a particular software tool like NV or ERDAS has data fusion. Several functions may be there for data fusion. So user gives high resolution image, low resolution image, output file name, and one can click on run, and you'll get the output. So that may be in default mode. So if the user is choosing, say, wavelet based fusion or a PCA based fusion, so why are certain inputs required? Why is the program asking for certain inputs? What is the meaning of it? What exactly is the algorithm doing to the input data? What is produced by it? So if a student has to understand this, apart from operating the software, one should also spend a little more time on understanding the algorithm and the technique behind those features of the software. So the lab courses don't emphasize this enough. Now, when student joins a master's program, what is the student's motivation? Some students are very clear they want to pursue, go up to PhD. Okay, then may join an R&D company or get into academics. But they are very clear that master's program is a precursor to a doctoral program. So there the student is very keen, wants to learn as much as possible. There will be also students who want a top of the line job in the best possible company. So they want to do everything they can to get the best possible grades, to have the best understanding of the subjects. They also put in a lot of effort. So these are the two groups of students that the instructor would be very happy to interact with. Okay, and in some cases, well, I get to hear, from some students who joined IIT Bombay, I just wanted to study at an IIT, at IIT Bombay. So I took admission. The student didn't care which branch, which department, which branch. He didn't care. He just wanted to study at IIT Bombay. So whether they are motivated enough after joining or not cannot be said. And in some cases, it may be a stopgap arrangement while appearing for job interviews. So they'll desert the MTech program and then leave in between. Well, we see in some departments, more than 25% students leave after the first semester, because by that time they would have got their university degrees and also the job offers based on their bachelor's. And last, okay, the student did not get a job, doesn't want to depend on parents for personal expenses, so takes admission in MTech. Particular student may not have any interest in MTech, but financial independence may be the motivation. So as an instructor, you have to identify among the students in your class who is who. So whether the students are falling in this group or in this group, obviously you have to devote more energy to this group of students. And these people, if they come up with enough interest, yes. And most of the research happens when the student completes the coursework and picks up a topic for the second year dissertation work. So the students themselves will come up with some topics if they are interested in pursuing PhD. They would have done some groundwork and they would say, so can I take a topic in this area for my MTech thesis so that I can continue on it further in my PhD? So the student may be following what's happening elsewhere in big universities in other countries or in India. And so the student himself or herself will do some groundwork. So if the instructor is able to, accommodate that, the student will have maximum motivation. Okay, and such students will also be keen to publish their work in conferences, and the brighter ones among them will also get a paper in a journal. So the instructors should be really familiar with the students of the class so that, the right student should be given the best encouragement for doing publishable or patentable quality work. Yeah, so the students sometimes, during your classes or when the student is thinking of a research area, the student should be encouraged to read up on the history of a field. It's sometimes, it will be real fun to see how people got their own interesting ideas, okay, which started a whole field. Okay, example I gave is obviously, Tower's theorem, which proved the basis for a huge volume of work. So since this training program is about AI, ML, and geoinformatics, so your students should have some exposure to some of these areas. Obviously, everything will not be possible, but some of these the student should have been exposed to. And the engineering fields, again, all will not be possible, but some of them, whether it's remote sensing, GIS, GPS, signal and image processing, linear systems, spatial analysis, virtual reality, simulation methods, and then machine learning areas like neural nets, support vector. I said dash vector machines because you have so many of them: relevance vector machines, support vector machines, etc. And then kernel based approaches. So can the student design his or her own kernel? And then various areas of machine learning. So these are very specific to the combination of geoinformatics and AI/ML. So today a lot of work is done on all of these things, but people continue to work, people continue to come up with new results, new applications. For example, I can give you one area. Say it is the vector maps. Raster data is like having a set of cells on a regular grid. So data is like matrices, rows and columns. But suppose your data is comprised of a series of XY coordinates or X, Y, and Z coordinates. So can you watermark such data? Watermarking, as you know, helps in authenticating or proving ownership of a data set. So if you have a digital map where you have the data points as X, Y, and Z coordinates, is there a way to watermark such data? Some attempts are happening, but it is still not very successful. Or extension of it is steganography. Can you hide messages and pass them on to others? Or if you receive, say, a vector map, can you search for any hidden messages? Image retrieval. So if you have very big databases, image databases, what is the most efficient way to retrieve images based on your query, which is also an image? So a lot of work is done, retrieving frames from videos or retrieving images from, say, when you have thousands of still photographs, retrieving all frames of a bird or a cat, or these things people have done. But suppose I give you a problem where, say, you have images containing some military targets, but there are also camouflages, there is shadows. So can you retrieve the relevant frames in a defense application? So, I mean, you can think of various new applications to an existing area. Object detection and classification. So this is forever an area of interest. So particularly object detection and convolutional neural nets together, people are merrily extending it further and further. Multi-resolution methods, you have wavelets, you have curvelets, you have contourlets. So you can say Xlets, where X can be one of these many different things. So can you have very efficient algorithms for implementing or new applications of these multi-resolution methods? Can you combine this multi-resolution analysis with, say, deep learning? Super resolution. Suppose you have an image. Can you generate an image of a higher resolution than what you have captured at? So you captured an image which has 2000 by 2000 pixels. Can you generate a 5000 by 5000 pixel version of it without taking a fresh photograph with a better camera? So in remote sensing, you have spatial super resolution and you have spectral super resolution. People are working on both. Similarly, with radar imaging, you have a combination of polarimetry and interferometry. Again, it's a big area of its own. In others, general, I mean, in spatial analysis, but with a GIS focus, some of these are kind of trying to re-evolve. So adaptive hierarchical processes, or AHP, cellular automata, spatial interpolation techniques, simulation, decision support, visualization, embedded systems. So you put a camera and maybe a processor together on a drone, and as the drone is flying, it gives you a full classification map and also maybe an elevation map, everything. can you think of such which will be very helpful for localized applications? High performance computing. So what takes hours, try to do it in minutes. What takes minutes, try to do it in seconds. And what takes seconds, do it in the blink of an eye. So you can keep, improving the computational performance. And how do you share the data? How do you make sure that you have interoperable data, interoperable processes, smart user interfaces? So can I ask, I am Krishna Mohan, show me the map of my residential plot. Can I ask a system like this and immediately see the map of my residential plot? Or that's one example. You can think of many more. Smart user interfaces. This was asked by one IS officer some years ago when we were waiting for, I think, a flight in an airport. He said, can you people develop this kind of things? It will be very useful for us. So critical infrastructure protection. Say recently we have seen the flooding in Hyderabad. Before that we saw in Chennai, etc. So if hospitals are going to be affected, how do you make sure that you are ready to move the patients from one place to the other with the available knowledge of transportation, etc. Knowledge of the availability of beds and treatment facilities, smart navigation, going from one place to the other and identifying all the barriers, etc. Digital agriculture and precision farming. There is worldwide interest in this. Automated image interpretation. So can a computer see an image and say, look, there is a train passing through whatever, train entering a tunnel, for example. Can such things be possible? So you can think of, and military target and change detection. The military people will forever be looking for, automation so that soldiers who are not tech savvy are able to use the systems, highly technology based systems with limited training. So I also feel that whenever courses are, some MTech semester long courses are conducted, there should be some hours devoted to guest speakers who come from the application fields, and they explain the relevance and application of the topics covered in the course. That is the best way to motivate the students. So there are difficulties if the decision making is centralized, more weightage is given to the end semester examinations, etc. But so these problems, I don't know whether there is any immediate solution to this. Maybe, with time, these problems can be overcome. Okay, so I can stop here. And I'm open to any more questions that you people may have. We have at least 20 minutes more. So we can have some discussion here.
So, I wanted to know, like, as part of master, many course projects are given.
Yeah.
So in that, is giving comparative analysis a good idea? See, we have a lot of network. When talking about deep learning, we have AlexNet, VGCNet, PointNet, ResNet. Is it worth doing the comparative analysis maybe on some standard data set or maybe some data set created by ourselves as part of
Uh,
mini project?
yeah. See, what I feel is let each student pursue one network. I mean, apply one network to the same problem with some common data sets, and those students together can present, the quality of results and the ease or difficulties they experienced, etc. So without you, uh, you know, doing it, let each student, suppose there are 6 different network models, let 6 students or 6 groups, uh, you know, do this, and they should all present their work together, so that the quality or the performance of the networks, the computational complexity, ease of use, everything the students themselves will explain to you, rather than you telling them, you do use this on this and this networks, and then tell me what is your analysis. So let 6 groups under thoroughly investigate, every group a particular net, and that way there will be collectively uh, a large pool of knowledge generated.
Okay, sir. Thank you, sir.
Yeah.
Uh, do we have any other questions?
One question is Mr. Ashish Paul.
Mhm.
How COVID-19 pandemic affecting the classroom teaching?
Yeah, COVID-19 is seriously affecting classroom teaching, no doubt about it. The reason is not every instructor is equally tech savvy. So how do you make your presentations so that students who are watching the videos can see everything clearly? When you are speaking, you know you should speak not too fast, not too slow. If you speak too slowly, it will look as if it is getting dragged, and if you speak too fast, something may be lost in case of poor audio. So you should have the right speed at which you should speak. You should have your slides with big fonts. You should have a good mix of text, graphics, and maybe XY plots, whatever you're using. You should have a good mix, uh, good everything with good contrast, good color combinations. So a lot of effort is required. So it is taking me nearly 3 times more effort for every class compared to when I was teaching in a classroom. All I needed was a piece of chalk and a clean blackboard, nothing else. I have I didn't even need much preparation, but now I had to, take all that effort, and I have to, have my pauses to see whether everybody is able to view the slides, everybody is able to hear what I'm saying, whether they want me to repeat something, etc. So, yeah, it is much harder now to have the same effect from a classroom interaction, you know, during COVID times when you are using a computer to reach out to your students.
There is another question, sir. Mr.
Yeah.
Avinash Das. What approach should I use in applying transfer learning to a deep learning model, which is already well established for learning?
See, if you say something is well established, you can think of a new application that is not attempted before. Okay, so maybe, I can give you examples. Say you have water bodies, you have, croplands, and then you have submerged crops. Okay, so in a remote sensing scenario, you know how water interacts with sunlight, in which wavelengths it absorbs, how in which wavelengths it reflects something. Similarly, what is the behavior of crops or green vegetation? Now, when you have submerged vegetation, so there may be, and why there may be, you will definitely get the signal recorded by the sensors, which is, submerged vegetation. Maybe the top of the vegetation is visible still, but there is a lot of return contributed by the standing water also. So if this is not explored already, so a flood application, or say building collapse due to, say, earthquake. So normal buildings, how they look during earthquake times, you may not be able to go to the affected sites and collect your own ground truth. But you know what the buildings look like in the normal times, you might have collected some ground truth. So can you make use of your knowledge and apply transfer learning techniques to, analyze new data? Whether you use deep learning or whether you use shallow learning is a different thing, but transfer learning and other your classification analysis approaches, combinations, people have tried some. If you have a new area, you can always try it. That's all I can say.
Any more questions?
Excuse me, sir.
Yeah.
So how can Google Earth Engine help us in studies like disaster management, and how can we learn more of it, sir?
See, Google Earth Engine gives you all the tools required for implementing geospatial applications. So it can fetch you all the data wherever it is. I mean, it can fetch you the data. It can help you with classification, analysis, etc. So Google Earth can give you a normal time image of the area that is affected by a particular disaster. And so now you should have your own image collected during the disaster time. Then you can upload it, you can analyze the normal time image using Google Earth, and use the disaster time image. So Google Earth Engine can help you analyze both and do your change detection and draw your inferences.
Okay, sir.
Yeah. In fact, some of my colleagues have used Google Earth Engine very extensively. Professor Y.S. Rao, one of my colleagues, is an expert in applying Google Earth Engine features for synthetic aperture radar image analysis.
Yes.
I think works have been published from your institute regarding rice field monitoring using Google Earth Engine.
Yes, yes. In fact, transfer learning for critical infrastructure protection, for flood and earthquake affected area identification, etc. So many of the things I mentioned, some work is already done by my colleagues. Similarly, my own students did some work like super resolution, etc.
One more question, sir.
Yeah.
This is from Ms. Dimple Shaz. Sir,
Mhm.
the real data sets we obtain will have a lot of noise and outliers. So can you tell a better way to get a noise outlier free ground truth data, especially in the LiDAR data?
See, LiDAR data, where do you get free LiDAR data? I myself find it very difficult to answer that question. Uh, so, yeah, those who are sharing that data should help you in identifying the outliers. Or suppose you are you have other ancillary sources of information, say Google Earth or something else. Uh, so you should take help of those to identify what could be outliers. But it's very difficult to say how you can do it. Depends on the area. Suppose your image contains